physical navigation or real walking is by far the best way to move around in VR, as it directly maps our physical movements to the virtual world. We use our body the same way to explore the virtual world around us as we do in real life, without having to rely on any controllers. But as a result, we're limited to the physical space we have available. One method is to magically expand our physical world available for us to navigate, and it is called redirected walking. This method utilizes how the human perceptual system integrates different sensory signals together and explores the limitation of our ability in sensing position, orientation, and movement. Basically, redirected walking manipulates users into believing that they are walking along a straight line, where in the physical reality, they're walking along a curved one. It causes people to change the direction of walking without noticing. In extreme situations, users could be manipulated to be walking along a large circle in the physical world over and over again, while thinking that they're walking along an infinitely long straight line in the virtual world. The implementation is relatively easy to understand. For instance, as the user moves forward from position A to B, you just need to rotate the virtual world slightly but consistently to one side. So the user would end up walking along a curved trajectory while thinking they have moved in a straight line. And if A and B are very far from each other, we might in fact return to the physical location of A, but virtually arrived at the position of B. And we could then go further along the same straight line from B to C, but in fact, we just again returned to A. The angle of rotation should be a function of the user's linear velocity, so that when the user moves faster, the world rotates quicker. The rotation should also be kept under a certain threshold to remain undetectable. We can also play the same trick on the user's angular velocity. So when the user turns around, you can make the world shift to one direction, resulting in them actually turning a bigger or smaller angle in the physical world than in the virtual world. A combination of adding a rotation distortion using both users' linear and angular rotation could quite dramatically increase the perception of the physical space available. Of course, this method requires a lot of programming and very careful design of tasks in the virtual environment. But it is a good example of how you could use the existing physical space in a creative way by understanding how human perception works.